Good morning, my dear friends. Welcome you all to my YouTube channel. So this is a high-rise building HVAC unit schedule. So in this project, we have 14 AHU, 11 FCHUs and around 800 FCUs. So in this project, we have two basement, one ground, two podium, one service and following 12 floors, and all the units are located in the roof. And there is no chiller, I mean the air cool or water cool chiller. The project has a district cooling or chilled water connection, which is feeding the water to all the AHU, FHU and FCUs. So if you are working in the contractor, you will receive the drawings like this from the client. So you need to know how to verify all the technical parameters, if the schedule is correct or not. And also as a designer, you need to know what change will come if you don't add the correct technical values in the schedule or in the design. So in today's video, I'm going to cover how to cross-check each technical parameters and how to select the units. So let's start the video. So you can see some very important parameters of design, that is the cooling capacity, like total cooling capacity, sensible cooling capacity, and a hidden latent cooling capacity which is not mentioned in the schedule. Then entering air like dry bulb temperature, wet bulb temperature, and the leaving air, or you can say the off coil. So the dry bulb and wet bulb temperature of the off coil. So this is one of the important parameters of this thing. So we need to have some clear understanding of how these functions are related from the psychrometry. And I will show you the formulas behind this one, and so you can verify all the technical parameters. So when you start any cooling load calculation, you have to provide the weather properties. So here I have given the snapshot from HAP software. So I have shown like Middle East, UAE, that is my current location. So I have shown that one. So here you can see the dry bulb, wet bulb, daily range, and some latitude, longitude, and different parameters are there. So if you are in UAE, then you have to follow the Dubai green building regulation. So as per Dubai green building regulation, the values are slightly different. So if you see here, the dry bulb temperature we have to consider 46 or 115, wet bulb temperature is 29 or 85. So as per ASHRAE, and it is like 107 and 75. Okay, so here it is 115 and 85 is slightly different. And if you go to Qatar, then you have to consider the local condition temperature like 46-degree dry bulb and 30-degree wet bulb. In Dubai it is 46 and 29, and internal it is internal room temperature we have to consider for the comfort like 23 plus or minus 1, and here it is 24, which is almost same. Relative humidity 50 plus or minus 5, and here also same 50 plus or minus 5. So if your project specification has any separate value for that project, then you need to follow that one. Otherwise, you can consider the ASHRAE general condition parameter. So let's quickly see what are these basics parameters, and we will quickly jump into the technical calculation. The first one is the dry bulb temperature. As you know, the dry bulb temperature refers to the ambient air temperature. So it is used to measure the sensible heat of the air. So the table which you see here, the indoor design condition, I have taken from Career Handbook chapter 2. So here various recommended indoor design condition has been given. Like for example, if you see this apartment house, what are the temperature you see here is a dry bulb temperature. It is in Fahrenheit. So in apartment house they have given 74 to 76 Fahrenheit. So these all are the indoor design condition temperature. So this all temperature is a dry bulb temperature. So then come to the wet bulb temperature. So you can see the an equipment like a sling psychrometer. So the sling psychrometer, the dry bulb temperature is measured directly. It has two gauges. The first one to measure the dry bulb temperature directly. The second one is the wet bulb thermometer, and here you can see a water soaked wick. That means a wet cloth. So the wet cloth is covered over the thermometer. So what will happen here? You will apply, for example, if you are applying some amount of air to this area. Otherwise, you are just simply rotating this handle fast. So what will happen? First of all, this wet cloth, it will take the temperature of the thermometer because it is covered now. So it will take the temperature of the thermometer, as well as now you are supplying some amount of air. So what will happen? The air has some heat. So that heat also will be absorbed by the wet cloth. So finally the evaporation will happen. So that is the reason the wet bulb temperature means wet bulb temperature is the lowest temperature to which air can be cooled by the evaporation of water into the air at a constant pressure. Okay, so evaporation effect reduces the temperature of the bulb, so thermometer reading is low. So as I mentioned, this water cloth, the wet cloth will take the temperature of this wet bulb, as well as it will take the heat of that supplied air. So what will happen? Finally the evaporation effect will happen, and the final temperature of this wet bulb, it will be low compared with this dry bulb temperature. So that is a concern. So the next one, you can see the particularly the value which is mentioned in the Dubai Green Building, that is the latitude. So same like a HAP, the latitude they have given 25 degree north. So this one also will affect the one thing, that is a latent heat, because you know the sensible heat means, for example, if you consider the building, the hence sensible load will come from the people, lighting, the equipment, like that. But coming to the latent heat, it will come like the exposed wall, the glass, this type of thing. So we need to consider the latitude also, because there is one more thing. If you read this point, the intensity of sunlight, so the intensity of sunlight received decreases when we move from equator to poles. That means hence the temperature decreases when latitude increases. Okay, so that is the reason particularly it is given in the green building. Also when you go for the manual calculation, I will show you how it affects. Okay. So the next one is relative humidity. So you can see here relative humidity, mostly for all the applications they have considered something like 50% relative humidity. Also in the green building regulation also we just referred that they have given like 50% for Qatar and also for the UAE. So relative humidity means, it means how much water vapor or moisture in the air with how much the air could hold at the current temperature. For example, consider now at this time I ate 5 burger. Tomorrow at the same time I can eat 10 burgers. That means I have ate like only 50% of what I can eat. Okay, so here if relative humidity 50% means, you can say that much percentage of water vapor, you can say that much percentage of water vapor saturated in the air, or the air at 50% of its water holding capacity for the present temperature. For example, we consider outdoor design condition for UAE, it is 46 dry bulb temperature and 29 wet bulb temperature. So the relative humidity will come 28.83%. Anyway, that is not the comfort condition. You know that the comfort condition means it should be 50% plus or minus 5. So if I lower the temperature, for example, for in the room I need 24 degrees Celsius for the human comfort. So if I lower the temperature from 46 to 24 degrees Celsius, the relative humidity will go high. So let me show you one example how it is done. So this is the online psychrometric chart for against this 46 degree dry bulb and 29 degree wet bulb. You can see the value. The relative humidity is 28.834% and the enthalpy 94. Okay, this one enthalpy I will tell you later, and humidity ratio also I will tell you later, 80.476. And against this one, now we are going to see for the indoor comfort zone what is the relative humidity will come. So the next one is, I consider the indoor comfort condition like 24 degree dry bulb and 70 degree wet bulb. For this case, I got 49.650 relative humidity. Earlier it was 28, now it is 49%. Now what happened? I reduce the temperature. So as you see here, if I lower the temperature, RH will go high. And next one is the daily range. So daily range, if you go to this Dubai, so what they have given, the daily range is 13.8 degrees Celsius or 25 degree Fahrenheit. First of all, just understand what is the daily range. The temperature difference between the highest and lowest temperature in a same day. Not consider like not between different days or different months. For example, we should not consider the summer hottest month higher temperature as a high temperature and the winter the low temperature. No, it's not the concept. It's like the same day what is the highest and lowest temperature. Okay, so we need to consider this daily range also for the calculation. So the next one and the final one is the humidity ratio. So you are studying this because in the next slides, the next points, we have some formulas. For that formulas, we need all these parameters. Okay, so the next one is the humidity ratio, or the specific humidity is the weight of water vapor per unit weight of dry air. You know, in the normal air, we have the dry air as well as water vapor. So we need to know what is the weight of water vapor per unit weight of dry air. For example, 46 degree dry bulb temperature and 29 degree wet bulb temperature, we will get the humidity ratio as 18.476. The same one you can try. Just now I showed here, you can follow the online psychrometry. It's 18.476 gram per kg. When it comes to room comfort condition, 24 degree dry bulb and 50% RH, you will get 9.336 gram per kg. That means the value will be reduced. So finally, if the temperature goes down, RH will go high and HR means the humidity ratio goes down. So the next one is sensible heat. So sensible heat, a heat transfer process that changes only the dry bulb temperature of air properties without the humidity ratio changes. So you can see this BOA line in the psychrometric chart. which is this one, the BOA, and you know that in the X direction of the psychrometric chart there will be a dry bulb temperature. So here this is the dry bulb temperature. In the bottom, the X direction, what you see here is the dry bulb temperature. So the BOA, that means the sensible means only the changes in the dry bulb temperature. There is no change in the relative humidity. So the next one is the latent heat. So a heat transfer process that add or remove the water vapor from the air through humidification or non-dehumidification process. So it changes the properties of humidity ratio only. Just now we saw what is humidity ratio, the weight of the water vapor or moisture per unit by weight of the dry air. So we just saw that one. So the humidity ratio means, so it will change only the humidity ratio and it will not change the dry bulb temperature. Let's see what is that. So we need to see DOC line from the psychrometric chart which I show now. So here, as you see here, the DOC, it's from the bottom to the above. So you know that this is this 40%, the 60%, the values mentioned here is a humidity. So it is going from down to high. That means the humidity is increasing, but it is not changing the dry bulb temperature. So the bottom one is the dry bulb temperature. So it's a very straight line. So there is no change in the dry bulb temperature. Only the humidity ratio is increasing. So now let's start the verification. The first one I have taken here is the air handling unit schedule. So for the exercise, the verification, I will choose the first one, this AHU unit. This is applying to the podium floor. It has the airflow rate of 1353 and the total load is, cooling load is 21.9 kilowatts, sensible load is 20.5. Also they have given the dry bulb, wet bulb. I mean this entering air means on-coil temperature. On-coil temperature means the indoor descent temperature. Okay, so off-coil means after the coil. So that is the off-coil temperature. So dry bulb and wet bulb for all this one is given in this schedule. So let's see how to verify this one and whether the schedule is correct or not. So the first one we are going to verify is the sensible load. They have given 20.5 kilowatt. So just note down this formula. Sensible load kilowatt is equal to density of air into Q. Q is the airflow of the AHU. It should be multiplied with the delta T. Delta T means it's a delta T I mentioned here, on-coil dry bulb minus off-coil dry bulb into Cp. Cp means it's a specific heat of the air at constant pressure. So the first one, density of air, density of air at 20 degrees Celsius, it is 1.204 kilogram per meter cube. Then Cp, specific humidity of air, it is 1.006 kg per kilojoule per kilogram degree Celsius. Then delta T, on-coil dry bulb minus off-coil dry bulb. So first for this project, on-coil dry bulb, for example, if you see here in this schedule, this point, this is the on-coil. So on-coil dry bulb, they have 23.7, 23.7, 23.8, 23.6. So it's almost 23 point something. So that means in this project, they have considered the indoor condition as 23 degrees Celsius. Okay, so when the air is given to the room, there will be slightly some slight heat transfer, heat increase will be there. So that's why in the calculation output, the cooling load output, it's showing like 23.7, 23.5, something like that. That means it is acceptable. So we have considered 23 degrees Celsius as the indoor descent condition. The output, software output shows 23.5, something like that. So I will detail explain this one in the cooling load calculation video. So now you can consider the concept like this. Then off-coil also they have shown. So let's see what is that. So now what I did is I just applied all the values in the formula. So 1.204, density of the air, then 1.353, this one comes from this one. Okay, so we have the airflow rate of AHU 1353 liter per second. I need, as per the formula, meter cube per second. So what I did is 1353 divided by 1000, I got 1.353. The next one is delta T. As I shown here, delta T is the dry bulb temperature minus on-coil dry bulb minus off-coil dry bulb. Okay, as I mentioned here, on-coil dry bulb minus off-coil dry bulb. So here, as you see here, the on-coil dry bulb is 23.7 degrees Celsius and the off-coil dry bulb is 11.2. So I just applied all this thing in the formula and I multiplied with 1.006. So as I mentioned, it is the specific heat of the air. Okay, now you can get the answer, that is 1.204 into 1.353 into 23.7 minus 11.2 into 1.006, that is equal to 20.48 kilowatt. Okay, so that is the sensible load for this AHU. So what you see in the HVAC schedule, so they have given the same 20.5, that means 20.48 is round off to 20.5. So it is correct. Okay, so sensible load is correct. We verified that one. The next step is we have to verify the latent heat. So in the schedule it is given 21.9 as a total heat. Okay, so the latent heat is not given. So we will see that how it comes. So the next formula for the latent heat, as you see here, latent heat kilowatt is equal to density of air. It is same. Just now we put 1.204. The same will come here, density of air into a constant value of 2454 into Q. Again it is in the meter cube per second. Okay, so we have to put the same value of this one, 1.353. Then delta W, there is a special parameter here, delta W. That means nothing. Just now we discussed the humidity ratio. So they are telling the same humidity ratio. So delta W is the moisture concentration difference, kg of water by kg of air, the same humidity ratio. So now we will see how to find out this one. So in our case, the on-coil is dry bulb 23.7, 15.8. Let me enter the same in the psychrometric chart. Then we will find out what is the humidity ratio, and similar to that one for the off-coil dry bulb and wet bulb, we will enter in the psychrometric. We will get the W2. Okay, so difference of these two, we will get the answer. The first one we will try with the 23.7 on-coil dry bulb and 15.8 wet bulb. And here now I entered the value, and you can see the humidity ratio. We got 7.995 gram per kilogram. So I hope you remember we need the answer in kilogram per kilogram. So this unit we will change later. So just note down 7.995 for the on-coil dry bulb wet bulb humidity ratio. So similarly for the off-coil dry bulb wet bulb 11.2 10.5, I will enter in the chart. So now this is the second case. I entered the off-coil dry bulb and wet bulb 11.2 and 10.5, and the humidity ratio is 7.637. So now we got two answers, delta W1 and W2. So now 7.995 minus 7.637, we got 0.358 gram per kilogram. As I told you, we need the answer in kilogram per kilogram. So I'm just dividing by 1000. So we got 0.000358 kilogram per kilogram. Okay, so now I'm going to apply all this answer in the formula. Density of air, you know that 1.204, the same one we entered for the sensible. Then 2454 is a constant value, the same one. 1.353 comes from the airflow. So here it is liter per second. I just divided by 1000. So I got 1.353 meter cube per second. And this one is coming from this one. It's a delta W. So finally I got the answer of latent load 1.431. So now I'm going to add this total load with total load means sensible load plus latent heat. So sensible load, just now we received 20.48 and latent heat is 1.431. So total is 21.931. You can verify in the schedule it is 21.9. So the sensible and sensible load and total load is exactly matching when compared with when considering this on-coil and off-coil. Okay, so this is for the AHU. So the next one here, we have lots of FCUs. So let me take one FCU for the examples. I will take FCU 1, 11 quantity. So here what happened? For this one here also same as I mentioned, chilled water supplying the water to the FCU, AHU, FHU, everything. And here also, here you can see the one different is there. Total load they have given, sensible load they have given, entering air, that means the on-coil temperature they have given, dry bulb and wet bulb, but there is no off-coil temperature. Okay, so we are, in this case we are going to find out the off-coil temperature just for your understanding. So now we verified all the value, so we can start the unit selection. So for the FCU unit, for example, you consider it is for in our case it is 118 liter per second, so it is very low. I will just consider slightly higher one, because then only we can understand the practical difficulty to select the unit. Okay, for example, I just consider 440 liter per second for the selection. So this is the product. So this is the product catalog of Carrier. So here you can see the airflow rate. It is given in CFM. Okay, so we got the answer in liter per second. So I just convert the liter per second to the CFM. So 440 liter per second, and I multiplied with 2.1188 to get the answer in CFM. It is 932.272 CFM. So now go to the catalog. So here you can see the CFM value, airflow rate, high, medium and low. There are three options are there. So always we need to select the unit at a medium speed. Okay, so here now we got the answer like 932. Okay, so here you can see different values in the 517, 676, then 1070. So this airflow rate is matching with our answer. Okay, but not only this one, we have to see some other factors. So let me show you what is that. So the unit capacity for FCU6, the unit is 5.89 kilowatt. So you know that 1 ton is equal to 3.52 kilowatt. So this 3.52 kilowatt is not electrical kilowatt. This is a mechanical kilowatt. Like you are saying, like 1 ton is equal to 12,000 BTU per hour. So similar way for the mechanical, 1 ton is equal to 3.52 kilowatt. So the total capacity 5.89 for FCU6 divided by 3.52, I get 1.67 ton. So similar way for the sensible load for the FCU6 unit, it is 5.3. So the 5.3 means 5.3 divided by 3.52, you get 1.5 ton. So now let's finalize the catalog from the catalog. Okay. So here the T1 condition 35 by 24 is a outdoor condition. Okay, so outdoor dry bulb and wet bulb 35 by 24 degrees Celsius, and for the T3 it's 46 by 24. So for us, our case, we consider 46 degree dry bulb temperature, and so we need to follow T3 not T1. So in here the unit size they have mentioned in ton, 1.52 ton, and you know that we just saw that we need 1.67 ton. Okay, so 1.67 means it is between the 1.5 and 2 ton. So anyway we can choose at least one unit from here. But the problem is, you know, in the T3 condition we need to see, because the ambient temperature is 46 dry bulb. So that is what suit for the Qatar and this Dubai. So in the T3 the unit capacity is going low, like 16,000. So 1 ton is equal to 12,000 BTU. So 16,000 means 16,000 divided by 12,000. So it will be something like 1.4 or 1.5 ton. And so this one is okay. This capacity is matching with us. But the problem is the airflow rate. So here it is 676.5 CFM. So what we need is 932.272 CFM. So this is really not complying with our requirement. So we need is 932 CFM. So second option we need to go here, this one 1070, because as I told, airflow rate selection should be done on the medium capacity. So 1070 CFM we need to follow. So what will happen, the unit capacity will go to 2.5 ton. Okay, if you select the unit based on only the total ton of capacity like a TR, then you can select 2 ton. But in the 2 ton the flow rate is only 676 CFM, but what we need is 900 something. Okay, so around 900. So this is not complying, and you have to go with the next size where it complies 1070 CFM. So the unit capacity, the total load will be high. Okay, and there is one more problem here. If you see this condition T3, they have given the indoor, they have considered the indoor temperature 29 by 19. But as I shown in the schedule, we need the indoor temperature like 23 degrees Celsius. Okay, so this 29 is not matching with the 23. So what will happen, we can get the derated capacity schedule from the same supplier they can provide. So in that derated schedule you have to check for the 29 degrees Celsius, it is 2.5 ton. I means 30,500. Okay, that means 30,500 mean it will be divided by 12,000. So it will be 2.5 ton. So when it comes to like the next one, like 24 degrees Celsius or 23 degrees Celsius indoor condition, surely this capacity will go low. Like instead of 30,500, it will be slightly low. Okay, so not we cannot expect too much low from here when it comes to 29 to 24 degrees Celsius, but there will be some small amount of reduction will be there. But I hope that that will not affect that much, because we are already in the very safe limit. Okay, 2.5 ton and 30,500. So now we check the airflow, it is complying. And second thing here, it is 30,500. We check the total cooling capacity. Here sensible cooling capacity is not given. Okay, so that is another issue here. So here important point is what normally happen, selection of unit mainly based on on-coil, sensible load and airflow. If sensible capacity is matching, automatically total cooling load will go high. So in our catalog we saw the total cooling load was given, but sensible is not given. But when you go for the actual selection, you have to ask the sensible load capacity also from the manufacturer or the supplier, because sensible load, you know, more than 90% of the load comes from sensible, because you know sensible load covers the people, light, equipment, floor, partition, everything. When it comes to latent, you will see the exposed wall, exposed glass, like that. So most of the load you can get from sensible only. So you can see in our schedule also, total kilowatt 1.66, but sensible is very high, 1.49, remaining the small amount like 1 kilowatt only latent heat. Okay, so as I mentioned here, mainly you have to focus on sensible load on-coil and airflow rate. Okay, so when you match the sensible load, automatically total cooling load will be more than the requirement. Okay, but second thing, like because I see sometimes the people are considering only the total cooling load instead of focusing on airflow. So we need to see airflow on coil. So on coil is another important thing, because the indoor comfort condition depends on coil. But there is another case. For example, air is taken from outside for FAHU. In that case, what will happen? If the air is taken from outside, then surely the latent heat will be high. Okay, latent heat will be high, sensible will be low. Means sensible will be very less amount, because the air is completely taken from the outside. Okay, so the latent heat will be high. So that FAHU selection and chiller selection and FAHU with the heat recovery will. So that selection we will discuss in the next video. Okay, because due to the very lengthy of this video. Thank you. Bye bye.